Hi, today we are going to talk about three very important functions: update, FixedUpdate, and LateUpdate. So let's see what these are about. Here we have the usual ground, yellow ground, and the blue avatar. They are not really right now behaving like avatars and ground, but the point is, on the avatar we place this all the updates component, right? And this is it, right? All the updates here, you see the preview, but let's double click on it and see how it really looks. There you go. What we have, well, of course, is a class that derives from monobehavior. That's why it's a component that we can drag and drop onto the avatar. And then there is the start function. Right now, everything in it is commented out, and we'll look at later what it means. The time.time scale is equals 0. For now, we skip it, and we go to update. All right. So update is one of those well-known functions like awake, on enable, and start, for instance, that Unity knows about, right? And you have to spell them exactly like this. For instance, if the U was not uppercase, Unity wouldn't think is that update function, right? So it has to be spelled exactly like this. But let's say it is, like in this case. So when is this called? Unity guarantees that it is called just before the next frame is rendered on the screen by the GPU, right? So it is executed by the CPU, and it is guaranteed to be executed. All the update functions on all the components and all the game objects are executed before the next frame is rendered. That means, how is this supposed to be used? Well, if we have code that we think may influence the position or rotation or whatever feature of a game object, probably we should do it in here so that immediately after it is picked up and reflected on what the main camera sees, and so basically what the player sees. If you wanted the changes to position and rotation as soon as possible are visible to the player, we should make them in update. But there is a caveat, right? It's not really true that all of these such changes should be done in update. When we should do it and when we shouldn't. Say we have a game object that has many components and none of them are a rigid body, then definitely one or more of those components may choose to have an update function that modify the position, rotation, and whatnot of that game object. That's the best place to put it. If among those many or few, whatever, several components on a game object, one of those is a rigid body, then those things that we can do to the game object that may change its position and rotation should be done in FixedUpdate. But not anything that can change the position and rotation. Those that are of the kind like a force that is applied to the object, or an impulse that is applied to the object, or a torque that is basically like a force but rotational force, right? That is applied to the object. If these are applied to the object, we should apply them to the object in FixedUpdate, because FixedUpdate is another well-known function that Unity knows about and treats differently from any other function, regular function, because it guarantees that it is called just before the physics simulation is run inside Unity. Unity checks if there is at least one object in the scene that has a rigid body on it, and if so, in that object and all the others that have a rigid body component on them, runs a physics simulation. So for instance, they can bump against each other, they can push each other, no, you name it. If we want to apply forces and things like that, torques, to these objects, FixedUpdate is where these applications should be done. Now, there are the usual remarks about making the game sort of time independent, right? We already went through it in other videos. Of course, in update, we always use Time.deltaTime, right? So that position rotations, they they take the same amount of time on different machines of different speed. On faster machines, the movements are smoother, but the same span, right? That's the idea. In FixedUpdate, we want to use Time.fixedDeltaTime. That's it, okay? And it is called FixedDeltaTime because it is always, by default, 0.02 seconds, meaning 200th of a second. That's it. You can print it on the screen like we are doing here, and we'll see it is always 0.02. What about Time.deltaTime? Well, we already know that it changes based on how fast the machine is. So a PC that is slow and goes at 30 frames per second will have a Time.deltaTime that is 8 times on average bigger than the one of a machine that runs at 240 frames per second instead of 30, right? So on a very fast machine, Time.deltaTime is 8 times smaller on average. But then again, it's on average, because even on the same machine, it varies wildly. Why? Because some frames have more objects in them, some frames have less objects, some frames have more, maybe there's different amount of physical objects on that move and forces applied. Moment per moment it changes, different amount of shaders, you name it, right? It can be anything. And we'll see when we will press play, right? We'll see that this one is always 0.02, this one is all over the place. Kind of roughly the same, but not ever really the same, not 2 times ever the same. Now there is a third function, LateUpdate. Now, as far as I can tell, there is only one very important use case for this function, that is moving the cameras. What I mean is that, again, is another well-known function. Unity executes it after all the update functions have been called on the active game objects, then it calls LateUpdate on all the active game objects. Kind of like start is guaranteed to be executed after all the awake functions are being executed. So here, LateUpdate is guaranteed to be executed only after all the update functions be executed. Still before the next frame is rendered, but after all the updates. That means that, for instance, if in a game you have 4 avatars, right, because it's a multiplayer game, and you have maybe 10 bad guys on the screen, okay? So there are 14 objects in total that move around. So the reading of the inputs, the keyboard, the mouse, the controls, is done in update for the avatars, and the artificial intelligence also is done in update, let's say, because they move around, and that's how it is done. I want to make sure that the camera has all 4 avatars and the 10 bad guys visible, right? So I want to calculate the smallest rectangle that contains all 14 objects, right? How do I do it? Well, first of all, I have to make sure that these objects are not moving, right? It's like taking a photo. You don't want the subject to be moving. And so LateUpdate is the best place to move and orient the camera, based on the position and orientation of the objects that are of interest to the camera, knowing that they are not moving at all, right? So that's why LateUpdate is the best place to move the camera. Maybe there are also other use cases, right? But I don't know about, I never read about any other than this one. It's a very important one though, and I started doing it. I started moving cameras in there. That was a short period of time though, because soon after I started using Cinemachine, and Cinemachine sort of takes care of this detail for us. I mean, there are options to change it and all that. But fundamentally it takes care of this. So one of the things that you don't have to do much of is moving cameras by hand. But if you are doing it by hand, then LateUpdate will be the place to do it. As I said before, in Edit Project Settings Fixed Timestamp, you can change the amount that FixedDeltaTime is. Again, by default is 0.02 to hundredths of a second. In some games, let's say they decide to commit to fixed 60 frames per second, V-synced and all that, right? And so they decide that the physics simulation should also be 60th 60 times per seconds executed. So instead of 0.02 is maybe 0.01666, you know what I mean, right? And that guarantees that it's executed 60 times per second, exactly like the frame rate, so that everything is all synchronized, and no, you can do those things just fine. And then time scale. Time scale, you know, if you were uncommenting this, the game would pause in a sense. And when time scale is 0, fixed update is not executed. Like the Unity engine knows that if this is 0, you probably don't want to run the physics simulation because you are pausing the game. And that doesn't mean that Time.deltaTime is not whatever value it has. It still has. I mean, if you use it, it is still, I don't know, 0.02 by default. But you know, just you have to know that. Okay. Let's see. Let's go back to Unity and let's run it. Let's see it in action. So this code that we just saw is on the avatar. And as you can see, produces a certain number of logs. And let's see from the start. It prints, of course, FixedUpdate in FixedUpdate is 0.02 exactly, you know, doesn't miss a bit, is always that amount. Time.deltaTime is 0.05, that is basically 2.5 times bigger. That's the first time. And then becomes 0.008, is super little. And then again is executed FixedUpdate in FixedUpdate, and then again 0.003, 0.0047, 0.0048. It's a bit all over the place, right? And mostly the same amount, but not quite, right? It varies quite a bit. I mean, 005, 002, okay, 399 is basically 436. You see, there's no real consistency, but that's okay. Certain things you want to do them update, certain things you want to do them in FixedUpdate. We already checked it out. And the cameras, we move them in LateUpdate. And that's about it. So, of course, there is no substitute for actually making games, and you know, to get good at it, you have to use things. I can only teach you the theory, and maybe together we do some more exercises, but you have to, you know, take the theory, remember it, and put it to good use. All right, good luck with that.